All right, it is the last piece of the Megachart. That's amazing. So chapter 12 is only one lonely column at the very end of this chart, and you would find yourself doing a regression test or a slope test if you have bivariate data. Remember, bivariate means two variables, but specifically they'd be two quantitative variables given to you as ordered pairs or on a scatter plot. This is how you would know that you would be in this column. Two quantitative variables. All right, and our goal in a regression test is to see if the slope is significant. Which is another way of saying, is there a linear relationship between these variables or not? So the test for slope is pretty simple. Our null is if there's no linear relationship, and that would be beta equals 0. And our alternate is that there is a relationship, which is beta is not equal to 0, or sometimes it is less than or greater than, kind of like on the others. This is basically saying there is a relationship, maybe I know what kind it is, and maybe I don't. And there's kind of an interesting thing that I haven't talked about yet, that this independence test that we did is whether there's a relationship between categorical variables or not. Independent variables is the same as saying there's no relationship, so these actually go together. The variables are independent is another way of saying that the slope is 0, and that's for quantitative versus categorical. And then the variables being associated is another way of saying they're correlated for, you use the word correlated only for quantitative, but that associated word could be used for either. So these are the same for categorical and quantitative, and that's kind of fascinating. I need a color I haven't used lately, so I'm going to use blue since I wasn't happy with my green. It's not because it matches the other blue one, but just because that's what I have. So this is the, I don't have a place to highlight up here, do I? Regression test, I guess. All right, there were 5, count them, 5 different conditions for this one. So we have random, and I'm not going to write the details of random, but they're random pairs. They're random and in pairs. In fact, this is kind of like paired differences now that I think about it. It should be yellow here. Oh well. Normal would be the residuals have to be normal, so you would plot them and look to see if they're not too skewed. Or you might make a normal probability plot and it would be approximately linear. Independent is still here, but I'm writing it further up because I have to leave room for 2 more. Independent is still the 10% rule, and I'm not going to write any more than that because we've written that already. Linear and equal variances are the last 2. So remember, for both of these, you look at the scatter plot or possibly the residual plot. Usually the residual plot shows it more clearly. Not the same as a plot of a residuals. Plot of residuals is like a dot plot or a box plot or a histogram, and a residual plot is a scatter plot of residuals. The residual plot and the scatter plot, or whichever one you're looking at the time, are not curved. We're not looking for perfection, we're just saying they're not curved. And equal variances means that the residual plot and the scatter plot has to be evenly spread, like icing on a cake. Yay, I've got it to almost fit in that box. Amazing. Calculations. The most important thing is, can you find it on the computer output, which I hope that you can, and I will talk about that when I go over the practice problems. But T officially is the sample slope minus 0, because the 0 is, again, almost always 0 in that spot. B minus 0 over SED. And you can find these two numbers on the computer output, or you can find T on the computer output. GF for this chapter is N minus 2. P is TCDF, again, seen that before, of either T and 999 and GF, or it might be negative 999 and T and GF, or it might be doubled. This is for greater than, this is for less than, this is for not equals. That's depending on your alternate. And then the calculator calls it a Linreg t-test, but I'm going to say I have never seen a problem about this on the AP test where you had to use the calculator shortcut, honestly. They almost, in fact, I'm going to say always, because I've looked at every single AP test that they've released, and I've never seen them not do this. They always give you computer output. So the chances of you needing that particular calculator shortcut are very, very small. I suppose it could happen this year for the first time, and that would be a surprise. So that was quick. It was just one column, right? No problem, right? Yeah. Let's go to the other side and finish this off, and then we'll be done with the megachart. So this is quantitative. I forgot to put that as part of what I typed. 1, 2, 3, 2. Ordered pairs, in other words, two variables that are numbers, would lead you to be doing a t-test for slope, or sometimes called a linear regression t-test. And sometimes, yeah, I'm just going to put slope tests down here. Our null for that is that beta equals 0. I'm not going to write the rest because it's on the other side, but I am going to highlight in blue. That's what I did on the other side. My blue is too dark, and I feel like I should find a better blue. That's okay. And then last but not least, we also learned how to do confidence intervals for slope. So you could possibly have to do a confidence interval for slope. And that is B plus or minus T star times SEB. And SEB usually would be given in the computer output. Officially, there is a Linreg T int on the calculator, but again, I really doubt you would need it. It's only on the 84. And then this little side arrow is if you don't have computer output, which I don't think they're going to do to you, but you never know, and you're trying to find SEB, you could find SEB by doing B over T after you do your Linreg t-test. So let me just put that up here. Linreg t-test on the calculator would give you B and T, and then you could divide them to get SEB if you needed it. I don't think you'll need it, honestly. In fact, I can safely promise you that you won't need it on my final. I will give you computer output for whatever problems come from this chapter. And on the AP test, pretty sure they're going to do that also. So that's it. Megachart done. Hurrah.